Right, okay, so I started off by drawing a diagram. We're told that the lengths of 5 both strings, 5 here, and this is the point 0 where it's attached. We're also told that the masses are M1 and M2. The first mass, we're told, has a radius of 3 as it spins around, and it's 4 below O. We're told that mass 2 has a radius of 7, so there's the 3, and there's the other 4, making it 7. So this would be all the way to there, would be 7. We're also told that it is 7 meters beneath O. So if there's 4, then that must be the other 3 there. So we've got these dimensions there. So what I did is I looked at M1 first, and I drew all the forces acting on M1. So M1 here has weight acting down, Mg. It has tension from this string that I've called T2, and there's tension from this string that I've called T1. Now the angle theta 1 here is the same as this angle theta 1 there, and this angle theta 2 here is the same as this angle theta 2 here. We've also got the tension from that string, and then we've got the centripetal force, which is equal to m omega squared r, which is opposing the tension, which is the same magnitude as the tension pulling in here. It's not acting outwards, but I just drew that to help my brain process it. So I've decided to look at the vertical forces on M1 and the horizontal forces on M1. So first off, the vertical acting downwards, we've got mg, and then the vertical component to this force T2, which is T cosine theta 2. And then we've got the vertical component to this one here, which is T1 cosine theta 1. So equation number 1, I've called it, is all the vertical forces. These are the 2 downwards, and this is the 1 upwards. I'm next on the horizontal forces. So we've got T2 sine theta 2, so this is the horizontal component to this force. Opposing that, we've got T1 sine theta 1, which is the horizontal component to this force. And we've also got the centripetal force, which is actually opposing this one here. So I've got that minus there. Okay. And then did the same approach for M2. So I did the vertical and the horizontal. This one's a bit easier because there's another string pulling on it. The vertical force, the downward force, is M2G, and the upward force is the vertical component of T2, which is this here, equation 3. And then the horizontal component is the tension this way provided by the horizontal component T2 is equal to the centripetal force action on that one, which is there. So we've got our 4 equations. Okay. So I identified the unknowns. I'm going to have to do 4 simultaneous equations, but if you're a bit sneaky, you can get away without doing them all. So all I did is rearrange equation 3 to give me this. Yeah. I then took equation 3, T2, and plugged it into this T2 here. So that gives us m2g over cosine theta 2. So this here is T2 times by sine theta 2, which is this sine theta 2, equals to 7 m2 omega 2. But we know that sine theta 2 divided by cosine theta 2 is equal to tan theta 2, and the m2's can cancel. So it leaves me with this. G, sine divided by cosine gives us tan theta 2, and I've got 7 omega squared. So now we can rearrange this to give us omega, which is this. We also know that tan theta 2 is equal to 4 over 3. So if I look at this, there's theta 2. Tan is opposite over adjacent, which is 4 divided by 3. So tan theta 2 is equal to 4 upon 3, 4 over 3. So that's this. So if I take this, substitute that into there, we get this, 9 1 times by 4/3 over 7 rooted. When you do the maths, it's 1.37, but all of the data that was given to us was given as a 2 sig fig, so they should actually be 1.4. That's going to be in rads per second. Hope that helps.